we're going to share this one. All right. So as soon as this kicks over, I will be ready to rock and roll. It's right now, it's not displaying properly as usual. Hustle and bustle. Let me make sure. Let's switch this over to. There it is. Okay, so that's loading. Let me go ahead and let whoever this is, let them in. Oh, see, that hasn't kicked over yet. Okay, so I'm just kind of trying to allow this thing a chance to warm up and behave properly. It doesn't matter. I need you to stop it though. That's distracting. Thank you. Let me try rebooting this. Sometimes that helps with this. If I go like this. Okay, still not playing properly. Come on. I don't know what else other than just wait. Okay, while we try to allow this a chance to display properly, no real announcements. I think Exam 3 is scheduled to open up this Wednesday from midnight. It'll be available from Wednesday at midnight till Saturday midnight. It is due Saturday, but again, we can work on these things past the deadline with a 10% late penalty. And there's a hard deadline of, if this is week 12, I think we only have a total of 14 weeks. So this is why normally I usually take this week to review for the exam. But what I'm doing this week instead, we only have 2 sections remaining that we need to do. So this week we'll do section 3.1, finally that kicked over. We'll do section 3.1, which is exponential functions. And then next week, maybe even this week we might just go ahead and finish out the lectures, right? Go ahead and do 6.4. Then we can take the remaining time to just review anything that we want to review, homework and stuff. Because it sounds like we don't have a lot of time. We're going to be done pretty quickly. Let me see. Let me check this. I think it's a chat.
Professor, I had a question.
Go ahead.
So, like, how much of the Alex do we have to have done before, like, the class is over?
The goal is for every person to be at least at the level of prep for college algebra or above, right? So I don't stress too much about Alex. Just kind of do your best with it. Just do the best you can with it. But the main thing is, like, the goal is for people to be at the level of prep for college algebra above. Just do the best you can with it. The main thing is definitely make sure that your Pearson is in order and just do the best you can with Alex. Okay? All right. Let's see. All right. So, okay. So, let's see. So, today, let me see the time. Okay. So, we got about maybe right at a full solid 30 minutes. Okay. Let's go view, single page. So today we're going to move into chapter 3, section 3.1. It's really just going to be exponential functions, right? So this is the only section in chapter 3 that we're going to do. Again, a timeline of events. So this is week 12. Again, exam 3 opens up in Pearson this week, right? And then next week is 13. So we only have 2 sections left. It's 3.1 and 6.4. And then the final exam is going to open up soon as well. So it should be there. You should be able to see the like when it's available and things of that nature. Um, and just kind of be on the lookout for the final and just kind of take it when it becomes available. And you get unlimited attempts. And just kind of be cognizant of deadlines and due dates. Everything is going to be due. And all I'm going to do, really, I'm just going to pull the grade from Pearson and kind of scale things like how we have it listed in the syllabus. And then as far as the weights of everything. And then, so basically your grade in Pearson is going to be 90% of your grade and 10% is going to come from Alex. Again, just do the best you can with Alex. Don't stress too much about it. Just do the best you can with it, and we'll go from there. Okay. All right. So let me see. Again, we'll do the best we can as far as this today. So I'm not going to cut it short. I'm just going to try to maximize the time and just kind of start walking through this section. And then, especially if we finish this in 2 days, I'll just go ahead and do 6.4 as well. That'll kind of stop us a couple of weeks early. We can take all the next week to be reviewing and practicing and getting things in order. And I think that's a better move instead of like forcing things to kind of wait. We can get everybody in here. All right, let's see who else we got. Let's go here. Here. That's good. But I think I got this whole thing down now. How to access other windows without disrupting stuff too much. Okay. So some objectives here. So we want to define what do we mean by an exponential function. We want to graph exponential functions, develop formulas for simple and compound interest. Those are fun. We want to understand the number e. We want to graph the natural exponential function and model with exponential functions. So these are some of the objectives here. Ephraim, I think he's in here. I just let him in. Yeah, I just let him in. Unless that was somebody else with his name. I think he's in here. Maybe not. I think I gave him attendance credit. Let me check. Is he getting some kind of error or something? Is he getting an error message? Yeah, I just let him in. I gave him credit. I saw his name. I tried to let him in. So I don't know. Okay. So an exponential function is a function of this form where the base is positive and not equal to 1. Again, we call this an exponential function with base a and exponent x. The domain of the exponential function is all rows, right? So in the past, we may have done power functions where we had x to some power. Now we're going to do some positive base not equal to 1 to the power of x, right? So that's what we're going to be doing with exponential function. Now the variable's in the exponent, and we're going to see, okay, what happens here. But again, the base has to be positive and not equal to 1. Okay? So this first example, it says, let f of x be 3 to the power of x minus 2, and we're asked to find f of 4. Oh, shoot. I forgot to change that name. I have to adjust it later. I meant to do that. I opened it up, and I went there, and it just did not update the name. I have to do it later. Let me see. Can I do it now? Yeah, I think I forgot to do it. Hey, thank you. Let me edit. Let me see if it'll let me do it here. That'll be awesome if it does. So I want this to be like this, and this. Get rid of all of that. This is supposed to be 3.1 exponential functions. This means money functions at 4 p.m. Tuesday, Thursday, 3:50. Alright, hopefully that updates properly. I'm gonna hit save. Okay, that looks good. I'm not gonna worry about it. So we're here. Alright. So for instance, this first one, so we're asked to find f of 4. All this is going to be is 3 to the power of 4 minus 2. So there's going to be 3 squared, so that one should be 9. All right. G of negative 2. So we're going to have negative 2 times 10 to the power of negative 2. A negative exponent causes it to go into the denominator. It becomes a fraction. It flips, right? So this is going to be negative 2 over 100. It becomes a negative 1 over 50. Okay, if anything is not clear, if I'm going too fast, you have to stop me and we can go back and talk about anything that we need to talk about. Okay. My dog has been quiet all this time, and then as soon as I start to go through a lecture, she wants to start singing. I'm like, you are hilarious. I think that's Archimedes' principle or whatever. Whatever can go wrong will go wrong. Anyway, the next one is h of negative 3 halves, right? Okay. So we have this 1 over 9 to the power of a negative 3 over 2, right? I think I need some space. I mean, okay, we can keep going. Get down. Thank you. So a rational exponent, what it means, this is the same as, okay, so first let's address the negative. This is going to be the same as 1 over 9 to the power of 3 halves. So a denominator of 2, that means square root, right? So this is the same as, we can honestly, I kind of want to do several steps in one. All right, I'm going to do this. So we're going to have 1 over the square root of 9, and then like this, but then all of this to the power of 3. So I kind of skipped several steps there. Square root of 9 is what? 3. So then this ultimately is 3 to the power of 3, which is 27. Okay? So we can honestly, and then this last one, I would just do it in a calculator. Right? So honestly, all of these, I think we can do in a calculator. So let me pull up Trusty Dusty Rusty calculator. It's going to be here, right here. And again, I am monitoring the chat. Feel free to unmute yourself or type in the chat if you have questions or if we need to go back. So let's see these in action in the calculator. Okay. So the first one was 3 to the power of x was what? 4 minus 2, close parentheses. The answer should be 9. Okay. The next one was negative 2 times, that's not times 10 to the power of negative 2. So I'm going to do parentheses negative 2. Okay. And we should get, I'm going to hit math as a fraction, negative 1 over 50. Okay. Next, we're going to do parentheses 1 over 9 to the power of x was, okay, parentheses negative 3 halves. I hope you all had a good weekend. I just realized, like, so it was Halloween for the country. You know, I didn't see any trick-or-treaters. I saw, like, some adults dressed in costumes walking around town, but nobody was trick-or-treating. Like, and, of course, I mean, with Corona, you know, You're not gonna. No sensible person would trick or treat in Corona. But not that it's not impossible. It's just I can see where a lot of parents would be like, "No, we're not trick or treating. We can go to the grocery store and buy some candy because that's all it is." But yeah, and then so the last one we get something like this, right? So we just did them all in the calculator. We got all of those results, and then the last one we just did it straight in the calculator. So I think these were all good. So we got the 1 over 50, which was the negative 0.02, 27, and we got that same decimal. Okay. So then we're asked to graph this exponential. It's like so weird. So if we're going to graph this, we can choose some values of x, find the corresponding y. So let's see, we get x, we get y. So let's go, let x be negative 3, negative 2, negative 1, 0, 1, 2, and 3, right? So we just chose some values of x, we're going to find the corresponding y. Let's do 0 first. So 3 to the power of 0, that's going to be 1. 3 to the power of 1 is going to be 3. 3 squared is 9, and then 27. And then if we go the other way, 3 to the negative 1 is going to be a third, and then a ninth, and then 127, right? So then if we plot these, I'm just going to do a rough sketch. This is the positive x in this direction, positive y in this one. Essentially, we'll get something kind of like this. Starts off close, and then it takes off like this. If we plot all of those x's versus y's, we get a graph like this. Okay. And then we have a computer generated, so I think they chose the same x values, got the same y's. They plotted the points, so you can see the plot to the left and then the graph to the right. Connected with a smooth curve. Already halfway. I love this class. It goes by so fast. I blink my eyes and we're already halfway. I'm sad and excited at the same time. I don't know how to feel about it. So I just choose one in the moment. Sketch the graph here, right? So we can do the same thing. Choose some x's. Let's choose some values of x, find the corresponding y. So, okay, let's go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Let's start with 0. So 1 half to the 0 is going to be 1. 1 half to the negative 1 is going to be 2. And then this is going to be 4, 8, 16. Right? Then going the other direction, this is going to be 1 half, 1 fourth, 1 eighth, and then 1 16th. Okay? So if we plot these ordered pairs, this graph, and again, this is just a rough sketch. I mean, I could like do tick marks and be precise and all this, but I'm just doing a rough sketch. This one's going to behave kind of like this. Okay. So I think they started with negative 3 when they plot the points to get this kind of graph. Right? So properties of exponential functions. So let f of x be an exponential function where the base is positive and not equal to 1. So the domain of the exponential function is going to be all reals. The range is the very bottom to the very top is going to go from 0 to infinity. But notice the 0 has a parentheses, which means we don't actually reach the 0. I know it looks like our graphs they reach 0, but they don't. The x-axis actually serves as an asymptote, which means that we get really, really close. We get infinitesimally close to it, but we don't actually reach 0. It never actually touches it. So if you zoom in, you'll always find space. The graph lies above the x-axis. So if we say the next y value divided by the previous y value, we're going to get a. So basically, what we're saying is, as we take one step in the x direction, the y value is increased by a factor of a, which is the base of the exponent. Okay. For a positive, we have, it's called a growth factor. We have exponential growth. Where's the other one? The function is going to be an increasing function. So as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to 0. That's when the base of the exponent is larger than 1. When the base of the exponent is between 0 and 1, this is called exponential decay, or we call it the decay factor is going to be a. That's usually exponential decay. The function is going to be decreasing. As x goes to negative infinity, y goes to infinity. But as x goes to positive infinity, y goes to 0. Every exponential function is 1 to 1. That means it passes the horizontal line test, which means every y corresponds to exactly 1x and vice versa, which means that it has an inverse. All of these are used interchangeably. So then because the exponential function is 1 to 1, if we have a to the m equal to a to the n, then that's going to be true if and only if the exponents are equal. And also, exponentials have an inverse function. Okay. There are no x-intercepts. The exponential function is a smooth and continuous curve. It passes through these key points. Basically, when x is negative 1, 0, and 1, with the corresponding lines. Again, the x-axis serves as a horizontal asymptote. And if we multiply the inside by a negative, it flips it horizontally over the y-axis. So instead of exponential growth, we didn't have exponential decay. Okay, so this is all just an introduction. When we start working examples, I feel like a lot of this just naturally comes out. Okay. So we have the interest rate. I swear she keeps waiting for me to talk. Like as soon as I talk, she makes noise. If I'm quiet, she's quiet. She keeps matching me. It's so funny. So the interest rate is a percent. She's doing it. It's so funny. Hey, come here. Come here. Let's distract her. Lay down. Right here. Come here. Lay down. Lay down. Thank you. Thank you. I just need you to be quiet for give me an hour. Can you relax for an hour? Get down. No. Come here. Here. Lay down. Because it'll be nice and toasty. Thank you. So, the interest rate is a percent charge for the use of a principal for a given period. The interest rate denoted by R is expressed as a decimal. Unless stated otherwise, the period is assumed to be 1 year, and so R is usually the annual rate. So the amount of interest computed only on the principal is called simple interest, right? So this is the first kind of interest formula that we want to introduce. I equals PRT. That's the lowest form of interest that we have. I equals PRT. Okay. Where P is going to be the principal or the amount deposited. R is going to be the annual interest rate expressed as a decimal, and the time is going to be it's going to be years. So time is usually years. Okay. So it says Juanita has deposited $8,000 in a bank for 5 years at a simple interest rate of 6%. How much interest will she receive? How much money will be in her account at the end of 5 years? Okay. So for part A, it says she deposited $8,000, so that means our principal is $8,000. The time is 5 years, and the rate is 6% as a decimal, which is going to be 0.06. So then we're going to use simple interest. I equals PRT. So that's going to be 8,000. The rate, which is as a decimal, is going to be 0.06. And the time in years is going to be 5. So then we just multiply those. Hey Siri, what's 8,000 times 0.06 times 5?
8,000 times 0.06 times 5 is 2,400.
So at the end of 5 years, it would have grown by $2,400. Decent. That's okay. How much money will be in our account? So then, for B, if we want the future balance, we're going to take her starting balance plus the interest earned. Right. So that's going to be the 8,000 plus the 2,400. Oh. All right. Let me see if I can find this video. Hopefully it'll let me do it. What is that? 10,400. Hang on. Let me think about it. How can I show it? I can pull it up here. Let me see if I can find it. Hang on. You may have seen this already. And I don't even know if it's going to let me do it, but I'm going to try anyway. Let's see if it works. Let's do this. No, not that one. Is this one? That's exactly what I didn't want to do. Let's hop back over here. Can we just have that like right here? That's fine. I just need you to open up. Come on. Are you not working because I'm connected? I don't want the remix. Okay. All right. So I'm going to try this. Hopefully it works. Let's see. So we're going to have a little bit of fun if we can get it to work. Hang on. Hang on. I got to get the audio working. Maybe if I turn this up. Hello, hello. Ooh, that's not it. Let me do this. Turn on. Okay, let's do this. I think this will work.
Jaden has $1 bill, 1 quarter, and 2 pennies. How much money does he have? Jaden broke.
His delivery was impeccable. All right, one more time.
Jaden has $1 bill, 1 quarter, and 2 pennies. How much money does he have? Jaden broke.
He did a great job there. I just wanted to share that because we were talking about all the stuff. I was like, oh, that is totally what's going on. Okay, let me put this back. Hopefully, all right, and then we got to go like this. All right. I don't know if y'all can hear that or not. Now I'm trying to get this to kick back over. Come on. Could y'all hear that okay? Can y'all hear me? Come on. What time is it? All right, we about to get out of here. Just trying to get this to kick back over. Let's go like this. Your volume is low. Is it still low? Okay. Let's go like this. So anyway, I don't know if you heard the video or not. Yeah. Okay. So yeah, the amount in the account after the 5 years is going to be 10,400. Okay. Okay. What's the time? We got 3:50. So we did all this. We got that, and we got that one. Okay, I think this is actually a pretty decent stopping point. Yeah, we'll go ahead and stop this here. So let me see. We'll make a note. So we stopped here on a Monday. Oh, this is what, November 2nd. All right, so election is tomorrow. So hopefully you've already voted. Okay, you're prepared to go the long haul. We're gonna make it through the night, and we'll be back on. Stop here Monday, November 2nd, 2020. So then what we're gonna do? We're gonna start here. Yeah, start here. Sorry, I need to push this back. Let me cut. Paste. Nope. Cut. Paste. Start here. Tuesday. If we survive, November 3rd, 2020. Okay, guys. I think that's enough. That's about the time that I like to stop. So we'll go ahead and close out here, and we'll just pick this up tomorrow, starting at 3:50. Okay. Enjoy the rest of your day. I'm here. I can hang around for a few minutes if you have questions. Otherwise, enjoy the rest of your day, and I'll see you tomorrow.